Okay, so I'm sure you guys are already enjoying the sessions, but as you know, today we've got another session from Nikhil from the Wormhole Foundation. He's going to be talking about native token transfers. So I'm sure you're all excited. And if you want to share your screen whenever you're ready, Nikhil.
Yeah, sounds good. Can you hear me all right?
Yep, can hear you perfectly.
Perfect. Let me share my screen. Give me one sec. Can you see this?
Yep, perfect.
Okay, awesome. Should I just get started now or?
Yeah, whenever you're ready.
Okay, sounds good. Well, thanks for joining me today, everyone. I'm Nikhil. I lead product at the Wormhole Foundation, and I'm super excited to talk to you about native token transfers, or NTT, today. So NTT is an open source framework that allows you to make any token natively multi-chain. And it's meant to provide you as an integrator, as someone who wants to take your token multi-chain, with a lot of flexibility for the long term. So one of the core design decisions of NTT is to be a protocol that you can use and that can evolve alongside your project as your needs might change in the future. So we're going to talk about native token transfers, but before we get deep into native token transfers, I want to talk a little bit about what the state of cross-chain messaging is today and the way we currently see things in the ecosystem, and ultimately what's motivated us to build native token transfers. So what's driving us to build something new? Native token transfers was released a few months ago. It's a new protocol. And when we were building native token transfers, we considered many different factors in building this framework. So we were looking at the entire market of multi-chain token standards, across things that people have launched previously. These other standards that are out in the market have varying degrees of openness. They have different levels of composability. They have different compatibility with blockchain platforms, and they also have different security assumptions and vendor lock-in considerations. And so these are all things that we looked at about other solutions, and that we sort of learned from them and incorporated into building NTT. So also looking at the ecosystem as a whole today, one of the first things we see is that cross-chain messaging is operating at a massive scale. So this screenshot is from the homepage of Wormhole Scan. And when we look at this screenshot, there are some numbers that pop out to us. The first one is that Wormhole has processed over 1 billion messages all time. The second number is that in terms of cross-chain token transfers, Wormhole has facilitated nearly $42 billion of value transferred cross-chain all time. And looking beyond the screenshot, we've done some analysis on the aggregate volume of interop protocols across the board. And in total, interop protocols across the board have processed over about $70 billion of value all time. It's probably a little bit more now, since that was done a couple months ago. So it's cool to see that Wormhole makes up a large percentage of that volume, but the cooler thing that this shows us is that cross-chain messaging is being used really frequently, and it's being used to transfer a lot of tokens. And as a result, it's reached a really impressive scale. The second thing we see today, just in terms of the ecosystem, is that interoperability protocols have sort of paved the way in terms of security. So generally, interop protocols. They have the largest bug bounty programs. They're also the most audited out of all crypto protocols. Another quick analysis that we had done a couple months ago was searching across top interop protocols on Immunefi, and we saw that there are over $20 million in bug bounties that were being offered by the top interop protocols at that time. I also looked through the security programs of these protocols and found that, in total, interop protocols have had over 60 audits done. And again, it's probably more now since that analysis was done a couple months ago. And all those audits are public. It's a standard and expected practice to make audit reports and mitigations to bug findings publicly available. And another interesting development has been that the crypto community itself has begun to develop standardized security frameworks to evaluate protocols such as interoperability protocols. And one example of this was the Uniswap Bridge Assessment Report that happened last year. That was produced by a committee of independent researchers evaluating the security of various interoperability protocols. They were using this set of clear criteria to evaluate these protocols. And the cool bit about that for Wormhole was that the independent Uniswap committee found Wormhole as the only unconditionally approved and the most secure protocol out there. Another similar assessment might happen this year or next year, and we're definitely excited to see the results of that. But overall, as a result of all of this work, most interop protocols are now expected to implement this standard set of security features. For example, it's the baseline expectation today that an interop protocol should use this sufficiently decentralized set of validators that attest to messages, and anything less than that won't get you very far. So cross-chain messaging has sort of paved the way forward in terms of security for the crypto ecosystem. And then the third thing we see in the ecosystem today is that cross-chain messaging is just everywhere. And the use cases for interoperability have really exploded. And so you see cross-chain messaging being used for all different kinds of crypto protocols, all the ones you see here, and more at the end, because there are so many more use cases beyond what's listed on this page here. And so another way of saying it is every crypto protocol is now thinking multi-chain. So this is where Wormhole native token transfers comes in to the picture. So NTT is an open framework. It allows you to seamlessly take your token multi-chain. And when you use NTT to take your token multi-chain, you are able to preserve certain characteristics about your token. So you're able to preserve ownership over your token, you're able to preserve upgradability over your token, and customizability of your token's features. And so in this way, NTT integrates with any kind of token, and you can preserve the custom logic for your protocol that's been built into your token. For example, if you have a governance token with voting rights, or a rebasing or restaking token, or a stable coin, or even NFTs. And this is an important point to emphasize, which is that NTT is not a token standard. It's a framework. It's open source. It's flexible. It's composable, and since it's open source, anyone can use it. Out of the box, it's a very configurable framework, and it can integrate with any kind of governance process. We can get into all the various things you can configure in some of the following slides. Another benefit of being open source and having these standardized interfaces and configurable parameters and custom payloads is that it's very composable. So you can integrate NTT into other DeFi protocols. You can also build on top of NTT if needed. And you can add features that might be specific to your use case. So to say it again, NTT is not another token standard. It's a permissionless and configurable framework for multi-chain token transfers generally. So there are a couple of different ways that you can use NTT. NTT lets you transfer new tokens or existing tokens cross-chain. So with new tokens, you can deploy in what we call the pure burn and mint model. That's what's shown on the left side over here on this slide. When you perform a transfer between a source and destination chain under this model, your tokens get burned on the source chain and then they get minted on the destination chain. And this is, in some sense, the purest kind of multi-chain token that you can have. That said, there are a lot of existing tokens already out there. Not all of those can be burned. Not all of those can be upgraded to be burned. And so if you have an existing token, you can make it natively multi-chain via what we call the hub and spoke kind of model, where you lock the token when you're transferring out of the chain it's already deployed on, and then you mint the new token that you deploy to the destination chain that you want to go to. And so that's that's the diagram that's shown on the right-hand side here. And these aren't the only two options you can pick from. They're just the most common options that integrators ask for and the most common options that we see. NTT is, in general, very flexible. And so if you have unique requirements for your own token, you can probably configure NTT, most likely configure NTT to fit your use case properly. And as I mentioned before, NTT is meant to be this configurable framework that protocols can use for the long term. All contracts are ownable and upgradable. So as a protocol, you have full sovereignty over your deployment. The fact that the contracts are ownable also enables important administrative functions for those contracts to be gated by whatever your protocol governance structure is. So for example, whether your protocol governance is a multi-sig or via actual on-chain governance contracts or another governance protocol that's on-chain, NTT can integrate with any of those, and you can execute administrative functions via any of those structures. Then via governance and via the administrative functions, you can configure exactly the right level of security that you need for NTT. So that means you can set access roles, you can set rate limits. NTT also allows you to configure inbound and outbound rate limits for every chain that you're deployed on. You can pause the contracts to stop all new transfers. You can also opt in to use a feature called global accounting, which is this token balance integrity checker that's enforced by the Wormhole Guardians. And you can also freely configure additional verifiers, whether these are custom verifiers that you maintain or other third-party verifiers. And among these verifiers, you can set threshold attestation requirements. So at a high level, those are the security controls that you can configure for NTT, but let's dig more into these because there's a lot there, and I think they're one of the things that help NTT stand out from the rest. So Wormhole contributors bake security into everything that we build, and NTT is no different. It offers defense in-depth security that's completely configurable. For every chain that you're deployed on, you can configure an outbound sending limit and per chain inbound limits. Wormhole contributors have a lot of experience working with security features such as rate limits. It's part of other protocols that we've built. And so if you set rate limits, we know that you need to prepare for the experience, for the user experience of being rate limited. So NTT also has this queuing mechanism so that users who get rate limited can still have confidence that their transfer is going to go through after more capacity opens up again. The global accountant is, as I mentioned before, a security feature that's enforced by the Wormhole Guardians, and that ensures that you cannot transfer more tokens out of an ecosystem than the amount that's been transferred in. So in that way, it enforces supply, balance, invariance. So these features of rate limiting and the global accountant, together with the owner and pauser access controls, they already cast a wide safety net for defense and depth security that protocols can benefit from when they use NTT. But NTT also has an extra step of flexible verification. When we were designing NTT and we were thinking about permissionless systems for the long term, we realized that those systems shouldn't have lock-in. And so with NTT, there's no vendor lock-in. You can freely manage adding or removing additional verifiers whenever you want. These verifiers can be custom verifiers that enforce your own protocol rules, or they can be other third-party verifiers. And between these verifiers, you can set M of N threshold verification requirements. So you could set 2 verifiers with a 2 out of 2 threshold, or any other of the configurations that you can think of, for example, the ones shown there. So this is a pretty exciting feature, I think, to offer to protocols. It empowers protocols to always have full control over the framework so that over time they can adjust it based on their own product evolution or the broader evolution of the crypto ecosystem. We think that having complete control over your own stack is non-negotiable, and so we therefore built NTT to accommodate for that. Going beyond just the NTT smart contract framework, NTT, just like all other Wormhole products, benefits from the full power of the Wormhole stack. So the Wormhole contributors have built this encompassing suite of products that makes going multi-chain a simple and robust process. And thinking multi-chain can be pretty complicated, and so we've worked pretty hard to abstract that complexity away while still empowering protocols to tune their integration. So NTT is integrated into this suite of products that Wormhole contributors have built. So Wormhole verification underpins the protocol. It's provided by the 19 Wormhole Guardians who need to attest to cross-chain messages before they are considered to be valid. Wormhole contributors are hard at work building ZK verification as well, other flexible verification models. There are a lot of ZK contributors, some of the premier ZK teams that we brought on to help build ZK messaging for Wormhole. So that's an exciting area of development in the realm of Wormhole verification. Wormhole Connect, it's UI widgets. I think there was another session on Wormhole Connect. Any project can easily pull Wormhole Connect into their own front end to access the entire Wormhole ecosystem of projects and products. Connect is also integrated with NTT, so anyone who pulls in Wormhole Connect can also start seamlessly transferring tokens across chain that use NTT. And any front end that already has Connect integrated can also leverage this new functionality by upgrading Connect. Wormhole relayers greatly improve the general just user experience of cross-chain messaging. Relayers are this network of delivery providers that get cross-chain messages from point A to point B. And when sending a message on the source chain, users or protocols, they're able to pay upfront for delivery to the destination chain. So greatly improves the user experience for cross-chain messaging. And then Wormhole Scan, we'll actually take a look at Wormhole Scan transfers later on in the session. Wormhole Scan is an explorer for Wormhole messaging. It's been built by Wormhole contributors, and it supports displaying NTT transfer details for any token that's integrated with NTT. So this combination of Wormhole Connect, Wormhole Relaying, Wormhole Scan, they're all things that enable projects. They're all products that enable projects to make transferring tokens using NTT this really smooth, enjoyable, one-click experience for users. Some of the protocols that are using NTT that we're super excited about. These protocols here cover the range of rebasing, restaking, and governance and utility tokens. So Lido is using NTT to power native transfers of wrap staked ETH between Ethereum mainnet and BNB. EtherFi is using NTT for their governance token, ETH5. Phantom is using NTT for their version of USDC on Phantom called USDC.E. This is a really interesting use case because USDC.E implements Circle's USDC bridged USDC standard, and NTT is enabling Phantom to smoothly implement Circle's bridged USDC standard while retaining ownership over this USDC.E contract, so that in the future, if and when Circle decides to support Phantom with a canonical USDC deployment and CCTP support, Phantom can transfer ownership of that token to Circle and perform whatever upgrades need to happen. So that's a very cool and exciting use case of NTT. GeoSol uses NTT to take GeoSol cross-chain, and OS ETH is Stakewise. They use NTT for OS ETH. And then the W token, which is Wormhole Protocol's governance and utility token, also uses NTT. So that's how the W token was made into a multi-chain native token. So we have talked about NTT at a high level. Now let's dive into some of the details. So this diagram here shows the entire life cycle of an NTT transaction. This diagram demonstrates a burn and mint transfer that a user triggers from a source chain to a destination chain. This could be Ethereum to Solana or between EVM chains. And let's walk through what is happening in this diagram. So the first step is the user will on the source chain, the user wants to transfer their token. They will approve the NTT manager contract on the source chain to pull their tokens from them. So then they'll call the transfer function on the NTT manager contract. The NTT manager contract will pull those tokens from the user. The NTT manager contract will then burn those tokens. And then the NTT manager contract will have a message that it sends to all of the registered transceiver contracts. And the transceiver contracts are, you can think of the verifiers in the entire scheme. I mentioned NTT has this flexible verification feature. And And so the manager will send a message to all of the registered transceivers. In this diagram, we only show a single transceiver, a wormhole transceiver. The wormhole transceiver will call into the wormhole core contract to go through the wormhole verification flow. If there was a custom transceiver, it would go through whatever other custom off-chain verification flow it would follow. And so this off-chain step here is kind of just detailing the wormhole verification flow. Then on the destination chain, the wormhole transceiver on the destination chain will receive the attestation from the wormhole guardians and the wormhole relayers. It will verify that attestation against the wormhole core contract. And then the wormhole transceiver will deliver that attestation to the NTT manager contract on the destination chain. And similarly, just as on the source chain, if you're thinking, imagine a multi-transceiver setup, just on the source chain, if we had multiple transceivers, we would send a message through each of those transceivers. On the destination chain, if there were multiple transceivers, those transceivers would each independently receive an attestation and deliver the attestation once they've determined it's verified to the manager, and then the manager will enforce that threshold attestation requirement, for example, 2 out of 2 or 2 out of 3 or 1 out of 1 or whatever that's configured to. And then when the manager has the proper number of attestations that meet the threshold from the registered transceivers, it'll proceed to mint to kind of continue on with the flow and mint tokens to the user on the destination chain. And that's an end-to-end NTT transfer. Okay, so let's look at a live example of an NTT transfer on Wormhole scan. Disregard the first point. I'm going to follow a slightly different process, but I do want to view the transfer on Wormhole scan and go through kind of the transactions on the explorers. I'll try to find a Solana, an EVM transaction, because I think that's the most interesting, but let's see what I find. So I'm going to stop sharing this screen and I'm going to open a new screen to share so we can look at Wormhole scan. All right, so this is Wormhole scan. It's an explorer for Wormhole that Wormhole contributors have built. And one of the cool things about Wormhole scan is you can see a bunch of stats. This is awesome. This is all great, valuable information and valuable data to see. But if you, let's say, you can go to this transactions page. And let's say you want to find a particular kind of transaction. You can go to the filters and you can filter transactions by the protocol of the transaction and by the source and destination chain. So this is super useful because you can really drill down and find the data that you want if you're curious to learn about something, you're curious to investigate something further. So here I'm going to filter by native token transfer. And I'm going to just say, let's see if I can do source chain as Solana and any target chain. So check that out. We have a whole bunch of NTT transfers from Solana to EVM chains, which is pretty cool. So this is a W token transfer, so we can maybe take a look at this one. And we can go through the transactions on the Explorer links. So we can click on the transfer, we can see some high-level details on the transfer, transfer from Solana to Arbitrum, advanced view. Okay. So we have the redeem transaction here, and we have the source transaction here. So let's look at the source transaction first. And let me share this tab instead. So here's the source transaction on SolScan, and we can look at the high-level actions that were taken. So the user transferred their tokens to the NTT program, And then these are, gas and rent payments. Then we can look at the details, so the instruction details. And you can see that they approved the transfer. That was the first step. And this unknown unknown is really the interaction with the NTT program, which is this program here. And you can see the accounts that were passed in. You can see the instructions. So create account, transfer checked. And you can see a whole bunch of instructions calling into the transceiver, ultimately emitting the event to the Wormhole Guardians. So this is the Solana side transaction. And then if we go back to Wormhole Scan and we look at the redeem transaction on EVM, let's share this transaction. Yep. All right, so this is the redeem. So this is the destination chain side where the transceiver is receiving the W tokens, or it's transceiving a message, or it's receiving a message on the Wormhole transceiver on the Arbitrum side. The Wormhole transceiver is going to send the attestation to the NTT manager. And for this deployment, there's only a single transceiver, which is the Wormhole transceiver. And so we should see when we go and look to the logs, a single attestation received event on the EVM side, and then the token mint events, since we're going to mint tokens to the user. But if we look at this, this is like, I don't want to do that. This is like the method that gets called against the Wormhole transceiver to receive the message. And if we look at the logs, we see the transceiver received the message. Now the manager is saying it got the attestation and it redeemed the transfer. And now the manager transfers W tokens to the recipient. So it minted and transferred. So from 000 to this user. So it minted these tokens and it transferred them to the user. So you can see all of the, and then these are because W is a governance token, you have some delegation related events. So these are the events that happen, and the actual on-chain transaction that happens when you perform an NTT transfer. All right, let's go back to the presentation.
Nikhil, we've got a couple of questions about the requirements for a token to be transferable as an NTT.
Oh, yeah, sure. Let me open up the questions. Okay. Which one? You're on mute.
The two most recent questions from Jamaru and Adam, just sort of about the requirements for
Oh,
it to be transferable.
That's a great question. Thank you for asking that. So the requirements are super simple. We also try to make the requirements as simple as possible. So I'm going to share this with you. This is the actual NTT code base. Example native token transfers on the Wormhole Foundation repository. And I'm just also going to drop this link here in the chat so you can take a look. And this is the iNTT token interface. It's the interface that a token that integrates with NTT needs to implement. So there are pretty much 90% of what's in here is convenience. So there are some errors that you can emit. There are some events you can emit. And then there are 3 functions here. And this functions, so I'll walk through each of these. The only 2 functions that are required are the mint function, which is not present in the standard ERC20 interface. But this is a standardized, this is a very standard function signature for the mint function. And then the burn function, which can be found in the OpenZeppelin ERC20 burnable interface. And this is the exact function signature for that function. So mint and burn are the only 2 functions that are required if you want to have a token that starts using NTT. And of course, this is just for like the minting and burning. If NTT can still integrate with a token that's deployed that doesn't have the mint and burn functions via the hub and spoke model. So let's say your token is deployed only on Ethereum right now, and you want to expand to, let's say, an L2 like Arbitrum. The token you deploy on Arbitrum will need to have the mint and burn functions, but the token that you already have on Ethereum, you can actually start using that with NTT without any change to that token. So you don't even have to touch or upgrade that token on Ethereum. Now this function, the set minter function, this is like a convenience function. It's not required. We put it into the interface because we like to encourage anyone who uses NTT to give themselves or to at least think about the capability to change the minter in the future. Let's say they want to they deploy a new version of NTT, or they want to do some kind of migration, or they want to, even stop using NTT, right? Again, one of the core design principles of NTT was to give people full flexibility. And so the set minter function is like a convenience function that we recommend people implement to be able to change the minter in the future. Does that make sense? Cool, I see a thumbs up in the chat, so I hope so. Cool, and in terms of requirements per chain, there really are no different requirements per chain. It's really just having, so this is obviously on EVM. On Solana, if you want to use like SPL tokens, it's pretty much the same thing. You will basically, if you have an existing Solana token, you don't need to make any change. If you have a new Solana token, you need to just provide the mint authority to the NTT program that you deployed. Okay, how can we transfer tokens that we don't have access to their smart contract? For example, transfer Pepe with Wormhole. Well, you can do that. You can take Pepe, that's on, I actually don't know what chain. Is it on Ethereum? Let's assume Pepe is deployed on Ethereum or Solana. I forget which chain it's on. Let's say Pepe is deployed on Solana. Like Pepe exists on Solana. You would deploy the NTT contracts. You don't need to make any change to Pepe on Solana because that's like an existing token. Then you can deploy EVM Pepe smart contract that you can deploy to Arbitrum, let's say, or Optimism or wherever else. And you can start transferring Pepe on Solana with your EVM Pepe token that you deployed on Arbitrum or Optimism or wherever else with your NTT deployment. Custom tokens. I'm not sure what exactly you mean by custom tokens, but what I think when I hear custom tokens is like your token is an ERC20 token and it has some custom functionality, like it has governance power, or it has extra rules because it's a stable coin, or it has extra rules because it's a restaking or rebasing asset. All I mean to say is that NTT can integrate with any kind of token. So there's no kind of additional thing that you need to do to be able to transfer custom tokens. It'll just work out of the box with NTT because NTT only depends on these mint and burn methods being present, and you retain upgraded authority and ownership over the token contract. Okay, let me answer these questions backwards. So NTT can be deployed. NTT can be deployed on any EVM chain. So if you want to use wormhole verification with NTT, you need to deploy it on a chain that's supported by Wormhole. But the beauty of flexible verification is that you don't like if you want to use a chain that Wormhole doesn't support today, you could write your own transceiver. So you could use a custom transceiver, and you can deploy NTT on an EVM chain with your custom transceiver that's not supported by Wormhole. And that's nice because let's say in the future, Wormhole does support that chain. You don't have to do any kind of token migration or anything to start using Wormhole. All you have to do is update your NTT configuration to like add the Wormhole transceiver, and then you can add Wormhole verification into the mix. Amount trimming and dust concept, only one paragraph in the NTT README about it. Yeah, so this is probably a little bit beyond the scope of, let's see, of this talk. But yeah, basically, NTT kind of like normalizes all amounts that are transferred to a certain number of decimals, and so that's what amount trimming is. And so let's say you have a token that has like 18 decimals, then what NTT will do is it will like, when you send that token, when you initiate a cross-chain transfer with that token, it'll trim the decimals from 18 to 8 decimals, and then that amount that got trimmed off is the dust. And so NTT will refund like the dust, or it will like either, I can't remember if it'll refund the dust to you or it just won't pull the dust from your account. Yeah. Okay. Let me see if there are other questions here. So I'm happy to continue answering questions, or an example. Yeah, so I'm happy to continue answering questions, or I think, let me see. I would like to show the NTT, like, so how to deploy NTT using the command line interface. I guess when you're asking for code examples, what exactly would you be interested in seeing when you say NTT transfer contracts? So these are the contracts right here. Are you looking for like how to integrate using SDK, or like an example of composability or something else? Maybe the transfer function. Okay, I can definitely show the transfer function if that's what people are interested to see. So we could look at the transfer function on EVM. So here's the transfer function on EVM. There are two transfer functions. One, you just pass in the amount, the recipient chain, and the recipient. In the other one, you pass in some more like info. But basically, the more info is refund address. So this is like when messages get relayed to the destination chain, you pay up front on the source chain, and any extra gas that's not used by the delivery provider gets refunded to you on the destination chain. And by default, the refund address is the recipient address, but if you want, you could specify a different refund address. Should queue is basically like, I mentioned that there's rate limiting, inbound and outbound rate limiting. And when you're sending an outbound transfer, and there's this queuing mechanism to make the experience to give some optionality and make the experience of just rate limiting a little bit more flexible and better. And so this should queue Boolean determines whether when you send a transfer and it hits rate limit capacity, do you want to queue it up, or do you want to just have it revert and return later to try again? And then the transceiver instructions is like really integrator specific. It's some transceivers you can pass. Basically, we provide the flexibility to pass in additional instructions to transceivers if there's any transceiver like specific stuff that needs to be passed in through the entry point. So that's the transfer entry point, and then basically that calls into this underlying function here, transfer entry point. Sorry, here it is. And here I would recommend, it might take a while to go through everything that's happening here. There's some upfront checks. This is the sort of burning or locking logic that's in this code block here. Then this is the trimming logic. So if you're curious to kind of dig more into the trimming, this is the trimming logic. And then we check rate limits. And then we call into another function, and the other function has some more checks. This prepare for transfer has some like internal calls that it performs. I would just recommend going through this code yourself if you are curious, since we have only around 12 minutes left here. But this will then perform some internal functions, call the transceivers, get some price quotes for delivery, and that's effectively what prepare for transfer does. And then this will kind of format and pack the bytes properly. That's what this section does. And then we send the message that gets packed up here to each of the enabled transceivers. And then we emit the event. So that's effectively what happens in the transfer function. Cool. Yeah, so there are also token samples. There's this, let me share this with you guys. If we go through the Wormhole repository, there's a sample NTT token repo. And that's a nice repo if you want to test out the deployment. It also has some deployment scripts. Example NTT token, I think. Yeah, so there's this repo, and you can try out using this if you want to see like an example token integration. Okay, cool. We have, okay, one more question. Examples for EVM Solana. Are there plans for an example for Sui? Yes, there are plans for an example for Sui. Something that was really cool was the Sui Overflow Hackathon just recently completed. Someone at the Sui Overflow Hackathon built an implementation of NTT. And so that was really, really cool to see. Wormhole contributors are now, taking a look at that implementation, reviewing that implementation, and trying it out. And so there are plans for an example for Sui. We're really excited about what the community built, and hopefully we can perform a Sui release and release something for Sui pretty soon. Yeah, that's exactly the one. Thanks, Urban. Okay, real quick, we have 9 minutes left. I'm going to see how much I can breeze through here, but I would really like to show you guys how to deploy NTT really fast using the NTT CLI. So the NTT CLI is this command line interface that a Wormhole contributor built to just improve the developer experience. Can you guys see my terminal?
Yep, we can see that.
Cool. And I want to see how much I can get to here. Hopefully I also have enough gas on testnets to make this happen. Okay, so the the first thing that you need to do to get the NTT CLI is you need to download bun, because that is a dependency. So bun.sh, that's a dependency for the NTT CLI. I already have it installed. I'm just like reinstalling it. Cool. Bun-sh help. That's here. That's installed. Let me see. Okay. So then there's an install script, basically for the NTT CLI here. We're working on performing an official release, but this is how you can, this is where and how you can install the NTT CLI today, is you can use this install script. So curl, pipe it into bash. This is effectively like removing the existing one, reinstalling the new version. So these are the installation instructions. Yep, I can share this this link here. Here, that's the curl script. Cool. So now it's deployed. Now we can verify it's there by doing ntt - version 1.0.0 - beta. So now the next thing we can do is we can see like the kind of the commands that are here. There's a whole bunch of things you can read, but the process you go through is you do NTT new and then you title a project. So let's call this Encode NTT. And this will create a new project. Effectively what happens behind the scenes is it clones the example repo, because each NTT deployment is project specific. So it clones the repo for you, and then you have access to all the code, and you'll basically run your deployment with access to all the code. So you'll build the code, and the CLI will help you take care of all that behind the scenes. So now I change directory into my new deployment. I run NTT init, and I need to provide a network. So I can init mainnet, testnet, or devnet. So I'm going to do NTT init testnet. Okay, and now you'll see what changed. There's this deployment.json file, and right now it's pretty simple. All it has is network, testnet, empty chains. Now I'm going to say, now basically before I move forward, I want to make sure I have the right environment variables. So what I want to do is I have a sample file here. So these are the environment variables you'll need basically is your private, I'm just going to show an ETH deployment. So my ETH private key needs to be set in the environment. And then the scanner API keys for like Etherscan, Arbitrum scan, Optimism scan, base scan. These are useful to have because when we do deployments, it's always good to verify, and you can verify the contracts using the scanner API keys. Difference between testnet and devnet is like devnet points to local net. So like if you're running a local net, like Anvil fork, that's what it'll attempt to deploy to. Okay, or like a local Solana validator, it'll attempt to deploy to that. Okay, so basically you set these environment variables. It's already set for me. So now we add the chain. So now you do NTT add chain. Okay, so it's giving me a bunch of instructions. I need to say what chain I want to deploy to. So let's say NTT add chain, and let's say I want to deploy to Arbitrum. So it's saying I have to specify a version. So we version NTT releases because Wormhole contributors and other contributors are constantly like improving NTT. We want to make sure that you're not deploying. If you want to deploy NTT, you don't just like pick up what's on main and deploy it because that might not be audited. And so the releases are what you should always trust for like audited, up-to-date contracts. So these are the available releases that NTT CLI is telling me, but you can just specify latest, mode. So I'm going to deploy in like fully burn and mint mode, and then token. I pre-deployed a token contract that we can use using, and this token contract, I just had pre-deployed it from the example NTT token repo. Oh no, what's going on here? Oh, that's because I'm doing the wrong thing. Arbitrum on testnet auto sets to Goerli, so I have to say Arbitrum Sepolia. There we go. So now it'll deploy to Arbitrum Sepolia. Sorry, there are no docs for the NTT CLI yet. We're working on getting that out soon, like as soon as possible, but no docs yet. So stay tuned for that. Also, if you guys are interested right now in using NTT CLI, definitely like reach out to me on Telegram, or reach out to other team members on Telegram. My Telegram is just my first and last name, and can get you in touch with Wormhole contributors, and we can help you guys out. All right, so this is taking a sec to compile. Hopefully it finishes soon. It's done compiling. The first compile always takes a while. Okay, cool. So now we see a whole bunch of stuff. It's deploying it's going to take 9 transactions to do this deployment on Arbitrum. And it's going to say all the transactions that get sent, and it's going to say all the config, like the initial config that's being set. So it's deploying NTT managers, deploying the Wormhole transceiver. It's making this initial configuration. So give it a second to finish performing this deployment and get all the transactions out. And the nice thing is also it drops all the transaction hashes, so we can like see what's going on. If you're curious to view these transaction hashes on Etherscan, or I mean, it would be Arbitrum scan for this example, but you can see what's going on. Okay, almost there. Fingers crossed. Okay, and now it's verifying the contracts. So it submitted all the transactions successfully. Now that it deployed the contracts, we want to do contract verification on Arbitrum scan, and that's from the Arbitrum scan or Arbitrum Sepolia API key that's in my environment. So give it a sec to verify these contracts. Almost done. Almost done. You can see a proxy contract. NTT is upgradable. All right, cool. So it deployed Arbitrum. That's great. And now if we like see what's going on here, we have this deployments folder that kind of tracks all the deployments you've done. And if we look at the deployment.json file, we see that it auto-added Arbitrum to this deployment.json file. Cool. And now let's add another chain because we want to go multi-chain. Let's add base Sepolia. And let's specify all the flags. So latest, mode burning, token. I also pre-deployed a token to base. So let me set that. Oh, and before I do this, I'm just going to do one more thing. You can do a skip. If you don't want to do the ether scan verify, you can do skip verify. I'm just going to skip verify to make it go like a little bit faster. All right, base should go really fast. Base submits incredibly fast, which is great. And now if we look at deployment.json, it added base to the mix. Okay, now you can do something cool. Now you can do NTT status. And you can see what the status of the deployment is. What you'll see is that there's some missing configuration and some out-of-date values. So these are values that are on the deployed contracts, but not in your deployment.json. And these are values that are not set yet on some basic configuration values that are not set yet on the actual deployment. So it's kind of like Git. You run NTT pull, and then you run NTT push. I'm going to run NTT pull. I'm going to pull the values that are on-chain, but not in my local deployment file. And that updated my local deployment file with the inbound limit, which is great to see. Now, if I run status again, there won't be anything left to pull. Instead, I need a push. So instead, I need to run NTT push. And what that's going to do is that's going to set, that's going to register the contracts with each other and set the basic configuration parameters. So that's what you can see here. It's registering the contracts with each other. This is something you need to do for security reasons to make sure that the contracts are all aware of each other on the different chains. Generally a good cross-chain design principle to adhere to. Almost done. Almost done. And now we're done. So now if we look at NTT status, we shouldn't see anything because everything should be configured. So up to date with the on-chain configuration. So that's like a full end-to-end deployment of NTT. So now NTT is deployed. It's integrated with our token. The last step that you would want to do is just set the minter of your token to the NTT contracts so that you can start transferring tokens cross-chain. But this is something that we completed in just around 10, 15 minutes. So that's the quick demo of how you can deploy using NTT. All right, so let me stop sharing my screen. And thanks, everyone. I guess, are there any other questions? Let me just check the chat.
We've had a couple more questions from Jamaru and Andre, and then also a lot of thanks for you. So sorry, it might get a bit lost in there. Oh no, they keep coming in. Jamaru asked, can we utilize Wormhole to build generic token bridges? And if so, with what technology?
Yeah, of course. So you can utilize Wormhole if you don't want to utilize NTT to build your token bridge, and you want to build something more custom. You can always build on top of Wormhole general message passing. And I think there might have been an Encode session on Wormhole general message passing, or maybe it was covered in just the overview of Wormhole. But Wormhole general message passing is like the core fundamental primitive that underlies the Wormhole protocol, and that, for example, NTT is based on. So yeah, you can build any kind of cross-chain protocol using general message passing.
And then I think Andre asks, what are the available NTT modes, burning and bridge? Question mark?
Yeah, they're burning and locking. So burning means that you're going to mint and burn on that chain. Locking means you're going to lock and unlock on that chain. And that's related to the hub and spoke model or the mint and burn model. So for example, you would use So an example of when you would use that is, let's say you have an existing token on Ethereum and you want to expand to Arbitrum. You would deploy NTT. If you don't want to upgrade your existing token on Ethereum, or you can't upgrade your existing token on Ethereum to have the burn and mint methods, you can deploy NTT in locking mode on Ethereum, so that on Ethereum, it'll lock and unlock your existing token. And then on Arbitrum, you'll deploy a new token with the burn and mint methods in burning mode. So it'll burn and mint your token. So that's the hub and spoke deployment, because Ethereum is like the hub chain where it gets locked and unlocked.
Cool. Okay. I mean, if there are no more questions from anyone, thank you so much, Nikhil, for an amazing session. And thanks everyone for your interaction. It's been great having all these questions. As always, these sessions will be posted on YouTube and we'll send you a link in the Discord so you can always rewatch. Are you happy to share the slides, Nikhil?
Yeah, we can probably share the slides. I can share that with you after this meeting, and then...
Yep, cool. And we can send it to everyone in the Discord. Okay, thank you so much, everyone. We'll see you next week.
Thanks, everyone. Thanks, Rebecca. Bye.